Welcome to this class. In this short session, we are going to discuss how to determine the equations of asymptotes for hyperbola. So first case, center 0, 0, transverse axis, the x-axis. So I'll draw the sketch. We have this. So this is the y-axis. This is the x-axis. This is the center. So they have this line here. So these are the two arms of the hyperbola. So these lines in blue are what we call asymptotes, whereby the arms of the hyperbola seems to be tending to as the value of x increases for this case. So these two lines, these are what we call asymptotes. So these two lines here. So if you remember for this case, the equation of hyperbola in this case is given by x squared over a squared minus y squared over b squared equals to 1. And then if, so this might be my f2, this to be my v2, this to be my v1, and this is to be my f1. And then customarily, the focus is always c units from the center. So remember, this is our center. So this is c comma 0. This is a comma 0. This is minus a comma 0. This minus c comma 0. So to get the equation of these two lines, let me call extend this one a little bit. To get the equation of these two asymptotes, So let me call this one L1, this other one L2. So if you draw a line here, so actually this is called lattice return. So from this point here, so you see, as the value of x increases in this case, this curve tends to be going closer and closer to this line L1 and L2, similarly to the left and then to the right. So around this point here, so let's make y the subject in this case. Remember, this is the equation, and then b squared is always given by c squared minus a squared. So from this one, y squared over b squared is given by x squared over a squared minus 1. Just take this to the right and then this to the left. So y squared over b squared equals to a squared x squared minus a squared. So I can say at this point here, when I draw this this line here, then this point is closer to this line here. So I want to assume that the limit of this limit as you approach this point here on the curve is closer to the same point on the line. So the x value we know on this line will always be any point on this line. In fact, even without saying an assumption, so this vertical line here, all points on this line will have the value of c. All values on this line will have a value. I will have a value of x to be c. So which means then I can replace this x by c. So I say y squared over b squared equals to c squared minus a squared over a squared. But c squared minus a squared is b squared, so this is the same as b squared over a squared. So it tells me that y alone, y squared, is the same as b power 4, b power 4 over a squared. So it tells me that y alone will be plus or minus b squared over a. So which means then on this curve, at this point, the coordinates will be c comma b squared over a, and then on this the lower value at this point here on the curve will be c comma minus b squared over a. So if you're asked to find the length of the lattice rectangle, so it will be the same as distance from this point to this point, which will be 2, because from here to here is the same as b squared over a, and then from here to here the same as b squared over a units. So the length of the lattice rectangle for this hyperbola is 2b squared over a. But that was not our interest. So our interest was to find the value of the equation of these asymptotes, these two lines here. So from x squared over a squared minus y squared over b squared equals to 1, then we say y squared over b squared equals to x squared over a squared minus 1. And then I can say then y squared is equals to b squared into x squared over a squared minus 1. and then getting the square root on both sides. So this, I can write this one as y squared equals to b squared, and then x squared over a squared into, so that I don't lose the meaning of the original expression, I have 1 here, then minus a squared over x squared. I hope you can easily see that these two expressions are the same, this and this, because if you open the b squared x squared over a squared times 1, you give b squared x squared over a squared, and then b squared x squared over a squared. When I multiply by this one, so a squared and a squared will cancel out, and then x and x will cancel out, and then I get b squared. So this and this are actually get the same thing. So this means that y alone will be the square root of b squared x squared over a squared into 1 minus a squared x squared. Remember, square root has plus or minus signs. And so this would be the same as y equals to plus or minus b x over a square root 1 minus a squared over x squared. And you see the way these lines behave with the curve, as the value of x becomes larger, both becomes larger to the large positive and large negative on either side, then the curve tends to be closer and closer to these lines we are calling the asymptotes. So therefore, the value of the curve, value of x and value of y on the curve can be approximated to be just the same as the value of the x and y on the lines here. So therefore you say, as x approaches plus or minus infinity, then a squared over x squared, this one tends to 0. Also making this denominator to be larger. So I expect that fraction to be a small number. So therefore, y would be given by plus or minus a over b x, because this now just be now 0, and then so 1 minus 0 is just 1. Square root of 1 is 1. So therefore, this is what you get. So therefore, the equations of the asymptotes are, from our labeling, this is our L1, the one that will go with positive sign, L2 the negative sign. So our L1 will be y equals to b over ax, and then asymptote L2 will be y equals to minus b over ax. So similarly, if I have b, case b, where the transverse axis is the y-axis, then this is what we have. So if this is the case, then we know that we'll have our V1 here, V2, F1, this F2, this is F1, and then these are the asymptotes. and this. So these are the asymptotes. So we know that the equation of this is given by y squared over a squared minus x squared over b squared equals to 1. So the coordinates of this 0c, this is 0a, this one will be 0 comma minus a, this will be 0 comma minus c. So making y the subject here, we'll have y squared equals to a squared, or simply, so a squared into x squared over b squared minus plus 1. And so y squared is the same as, this can be written as a squared over b squared x squared into 1 plus b squared, b squared over x squared. I hope this will make sense. So when you open here, this is the same as a squared x squared over b squared plus a squared. So this is the expansion of this one here. And you see what I've written here is the same thing. When you open, I have a squared, x squared, b squared, and then b squared and b squared will cancel out, x squared and x squared will cancel out, so that I remain with a squared. So this and this have the same meaning. And to get y, you say square root on both sides will have y equals to plus or minus a over b x square root of 1 plus b squared over x squared. And you see this one here, as x approaches both positive and negative infinity, then the quantity b squared over x squared approaches 0, because we are dividing by a big positive value. So which means then, which implies that the square root of 1 plus b squared over x squared will be approaching a square root of 1 plus 0, which is the square root of 1, which is 1. So therefore, y would be plus or minus a over b x as the final answer, because this will be square root of 1 times any number meant to the same number. So therefore, the equations of asymptotes are y equals to a over bx and y equals to minus a over bx. So these are the two equations. And quickly, you can just now, when you shift the origin, we have the same thing. So just get C. If this is what we have, our center, our transverse axis parallel to the x-axis, and then say and then these are the So this, if this is the case, so this H comma K, so this is our V1, this is our V2, this is our F2, this is our F3. Then the equation takes the same form as case A, but then now what you do is the shift in X, H units, and then shift in K units in Y. So asymptotes are given by Y equals to plus or minus B over A. So Y are given by B. So you remember that in the first case, the asymptotes were Y equals to plus or minus B over AX. So the same structure, B over A, but then X minus H units, and then plus K. Or you can write the same thing as saying Y minus K equals to plus or minus B over A, X minus H. So from which you have now two of them. So one, Y minus K equals to plus or minus. Okay, it's just now positive one. Let's write it independent of the negative one. So B over A, X minus H, or saying Y equals to B over A into X minus H. And then when you take minus K to the right hand side, it becomes positive. So X minus H, then plus K. And we'll have Y minus K equals to minus B over A into X minus H. Or you can say Y equals to minus B over A into X minus H plus K. And then for case D, the last case when now the transverse axis is parallel to y-axis, it's very easy to actually get the same answer by saying, so D, when this is the case, so this this our this is a hyperbola. Then so another the equation of this one is given by Y minus K squared over A squared minus X minus H squared over B squared equals to 1. So just say y minus k squared over a squared equals to, taking this one to the right hand side, we have x minus h squared over b squared minus plus 1. And so y minus k, when you make it a subject, will be a squared x minus h squared over b squared plus this is a squared. Just multiply both sides by a squared. So this is a square here. So it tells you that you can write y minus k squared equals to a squared x minus h squared over b squared into 1 plus, this I'll write it as a squared over x minus h squared. I hope you can see that this and this are the same, because this are close on this one, and then this two and this one get a squared here. So this means getting the square root on both sides will give you y minus k equals to plus or minus a into x minus h over b square root 1 plus b squared over x minus h squared. And you reason similarly that as x approaches plus or minus infinity, then this fraction b squared over x minus h squared approaches 0, which means, which implies that the square root of 1 plus b squared x minus h squared approaches square root of 1 plus 0, because this part will be 0, which is equals to square root of 1, which is 1. So therefore, we'll have from this point here, y minus k equals to plus or minus a over b into x minus h. And then this will be just the square root of 1, which is 1. So therefore, the asymptotes are y minus k equals to a over b x minus h, which is the same as saying y equals to a over b into x minus h plus k, and y minus k equals to negative a over b into x minus h, which is the same language as y equals to minus a over b x minus h, then plus k. So these are the asymptotes for the hyperbola whose transverse axis is parallel to the y-axis, and center is h, k.